I just wanted to show you how to do the fine-tuning adjustment on the ADX to ensure that it's transmitting on the correct frequency, effectively adjusting the VFO. Now, in the ADX at the moment, I have a 20-meter bandpass filter installed, and when I apply power to the ADX, you can see that the band light flashes 3 times for band 2, which is the 20-meter band, and then it defaults to a continuous display of the mode, which is FT8. So this is currently configured now to operate on 20 meters for FT8. The setup I'm using is the ADX is connected through to the barber watt. Doesn't need to be there, but I've just got it there at the moment for the purpose of this demonstration. And it goes through the antenna switch there, out through my normal antenna tuning unit and an antenna selector switch. The antenna switch here selects the different radio that I want to connect to. The antenna switch is straight out to the end-fed half wave, which is sitting in the front yard. So if I power down the ADX by pushing on the transmit button, I've currently got 2.7 watts going out to the antenna, which has got an SWR 1-to-1-2, so quite an efficient antenna, and it's working well. Now, I also have my IC7300 set up here at the moment. Now that's also tuned to 20 meters on FT8, but it's not connected to any antenna. There's enough radiation from the antenna outside and also the antenna here, or when I switch through to the dummy load, it will be able to pick up some of the transmissions there. So we can actually see what frequency it's transmitting on. Now, the way the IC7300 spectrum scope works is that when I'm set at 14074, the 0 point that's shown here on the spectrum scope is actually the middle of the upper sideband, so that when I press the transmit button here, you can see I'm actually getting a signal there, which I've deliberately off-tuned a little bit before this demo. So it's coming in at around about, it looks to be about minus 250 or something, or sorry, it's reading about minus 1.2 kilohertz. Now that carrier should be sitting at minus 1.5, which is the bottom section of the upper sideband envelope. Now, so 0, if you will, is the midpoint of the upper sideband. So if I go up to WSJT-x, which is sitting here working away at the moment, you can see the number of stations coming in. I've just finished working a VK5 over there at the moment. If you come here and you look at the transmit offset, I've set that to 1500 hertz. And when I come across and hit the tune button, there we go, hit the tune button, the ADX goes into transmit, and you can see here that the 1500 hertz offset is a little bit high. That should be sitting at the 0 point. Now, if I want to, I can twist the antenna, sorry, the tuner just a little bit there, and you can see, there you go, it's about, whoops, it's about 250 hertz too high. So I need to adjust the frequency down, and I'll show you how we do that. And for those that are interested, the connection that I have going here this evening is the ADX is connected via the speaker and microphone jacks, a couple of cables that just run across there into the sound card, which is plugged into the little nut computer there, which is then running up, being displayed up here on the screen. Now, in order to put the ADX into configuration mode, frequency configuration mode, let's just zoom in a little bit there. What I need to do is to turn off the ADX, and holding down the calibration button that you can see here, you hold it down whilst you power on again. You'll see the band light start to flash, and they'll flash 4 times, and lift the finger off the switch whilst it's doing that flashing. The fact that these 2 lights have remained illuminated now indicates that I'm in frequency configuration mode. Now, the frequency is calculated by the ADX routine from a number which is stored in the ADX, and we increment or decrement that number by pressing the left and right buttons that you can see here. I think it's actually a denominator calculation. So if we increase the size of the denominator, the actual frequency will reduce. If we decrease the size of the denominator, the frequency will increase. So in this case, we actually wanted to bring the frequency down to get it exactly on frequency. Now I can do that by pressing the button. So I want to increase the number to bring the frequency down. I can press it 1, 2, 3, 4, 5, but sometimes you have to make quite an adjustment to that number. If you hold the key down, the button will auto repeat and it will effectively increase the number that's being stored at a much more rapid rate. So in this case, I'm going to hold it down for about 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then having removed it, I'll then press the transmit button. It'll flash 3 times, then it will reboot the device and read the new thing from memory. So this time, when I press the tune button, if we look over on the 7300, you can see that little adjustment there, holding it down for 10 seconds, has lowered the frequency of transmission. So I need to go back and repeat that process. I'll just stop it transmitting, turn the power off, holding the calibration key down, repower up, remove it before it finishes flashing, and now I need to probably bring it down by about the same time, maybe another 12 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, a couple more for good measure. Now we'll store it into the device, and we'll again press the tune button. And this time we've actually actually no, I've got to adjust the main dial here. You can see there that I'm currently about 10 Hertz out on the scale there. Now that's probably as accurate as it needs to be, because I can play around and try and get that down to exactly 0, but I'm quite happy with that being at a couple of hertz of the actual transmit frequency. And by the way, I switched that across to the dummy load there on the ADX so that I wasn't radiating whilst I was doing that. So that's all there is to it. Let's just stop the transmit there at the moment. And so that ADX is now tuned to the required transmitting frequency.